topic we are going to discuss is about your torque. So first I told you what is a dipole. Now we will discuss what is the meaning for a torque. Before getting into torque, I want you to know the definition for what is a couple. So here generally when we talk what is a couple, we talk about a man and a girl, a male and a female together. We call them as a wedding couple when they're going to get married. Same way here, there have to be two charges which are unlike. So if you have two unlike charges, then we call them as a couple. Always couple will act in opposite direction. Say one force is acting along your y-axis, the other force will act along your negative y-axis. One is positive y means the other force will act in your negative y-axis. Little more simpler, one is acting in the upward direction means the other force has to act in the downward direction. So a couple will always be two unlike forces acting in opposite directions. So whenever we have a couple, you will have a twist which is formed. So when we have a twist, that twist will give rise to a torque. So this is how you have to understand. What is a couple is two charges which are acting in opposite direction. And when they are acting in opposite direction, they will produce a twist or they will produce a turning effect. That turning effect will give rise to a torque. So when we talk about a torque on a dipole moment, you see there are two charges plus q and minus q and they are separated by a distance of 2L. So automatically this combination is called as a dipole. And when we take a dipole, you imagine the charges are making an angle of theta degrees. Then dipole moment will always be from negative towards your positive. So you have this arrow mark given here. And these are your electric lines of force. QE here is because of the first charge. Look at the direction in pink color which is indicated. This is because of your negative charge. You can see the direction. It is along your negative x-axis. Look at the other arrow mark. It is given because of the charge plus Q and it is due to your charge of the positive. Direction is along the positive x-axis. One is moving forward, the other line is moving backward. So this constitutes a couple. And always when one is moving forward and the other one is moving backward, we will have a twist which is produced. So you can see clearly here the pink line is indicating how force is acting. So both the forces are acting along the opposite directions. So when they are acting along your opposite directions, automatically they should constitute a couple. So what is a couple? Definition, fix it in your mind. Two unlike forces acting in opposite direction, we call it as a couple. A couple will always produce a twist. That twist will give rise to a torque. So the force of magnitude small p, which is your dipole moment, capital E, which is your electric field. So the force is denoted with the symbol PE, act opposite to each other. Hence, net force acting on the dipole due to external uniform electric field will be 0. You can see capital E here. Since the external uniform electric field, when you recall how we drew lines, if it is uniform magnetic field or uniform electric field, you should have parallel lines which are indicated in yellow color. So this electric field from external on the dipole will be equal to 0 because force on the dipole are acting in opposite direction. So there is no translational motion of a dipole. See, there are three types of motion. One is translational, that is along a straight line. Second one is called as your rotatory motion. So rotatory motion means it will moving along a circle. Third type of motion, we call it as oscillatory motion. Oscillatory motion is your to and fro motion. How you have a pendulum, like that if you're going to move, we call it as the oscillatory motion. So three types of motion. One is translational, that is along a straight line. Second one is rotatory motion, it will be along a circle. Third one is oscillatory motion, to and fro motion, just like your pendulum or your swing. Here for a dipole, since electric field is becoming zero, there will be no translational motion. It cannot move in a straight line. So if it is not moving in a straight line, automatically it should have a rotatory motion or it should have a twist. However, the forces are along different lines of action and they constitute a couple. Keep in mind, couple means they have to move in opposite direction. Hence, the dipole will rotate. So it will have the second type of motion, that is your rotatory motion, and it will experience a torque. So torque will be produced only when two charges rotate and they are rotating because of your couple. This can be 1 mark question. Does a dipole have translation motion? Your answer will be no. It has only rotatory motion because of the couple and that will give rise to a torque. So we have the formula for torque here. Torque equals electric force into perpendicular distance. So electric force, here we have written the symbol is Q into E. Now you know the formula for sine theta. Dhanlakshmi, what is the formula for sine theta? Sine theta. Your mic is on. Devika. Formula for sine theta. How do you define sine theta? Kavishri?
1 minus cos theta, ma'am.
I want it in terms of sides of a triangle, in terms of opposite, adjacent, and hypotenuse.
Opposite by hypotenuse.
Opposite by hypotenuse.
Very good. Opposite by hypotenuse.
Hypotenuse.
Kulsum, what is the formula for sine theta? You raise your hand.
Opposite by hypotenuse.
Very good. Opposite divided by hypotenuse. So here we have theta. Opposite side is towards your plus q side and hypotenuse is the line between the two charges plus q and minus q. So if you want the value for theta, sine theta equals opposite divided by hypotenuse, but I want this distance, I want the perpendicular distance. So that perpendicular distance will be equal to the hypotenuse multiplied by sine theta. Keep in mind, sine theta equals your perpendicular distance divided by hypotenuse. So if I want perpendicular distance, it will be, we'll multiply your hypotenuse and sine theta. That is a formula here. Electric force is equal to QE. Perpendicular distance is equal to 2L into sine theta. Now when you take this, Q into 2L is nothing but your dipole moment P. So replace that. Q into 2L is P. Write capital E as it is and sine theta as it is. So torque equals PE sine theta, or we have two formulas. One is called as dot product. The other one is called as cross product. Dot product means it is A dot B. That is AB into cos theta. If you take cross product, A cross B is AB into sine theta. So look at this formula. It is PE into sine theta. So in vector form, I can write it as the cross product of P and E. So it will be P cross E. So torque in vector form is T vector is equal to P cross E vector, or you can write T is equal to PE sine theta. How this is derived, I'll show it to you little shortly. So this is the direction of your torque and it will be perpendicular and into the plane containing P and E. Perpendicular distance and it will be into the direction of P and E. SI unit of torque is Newton meter, capital N and small n. So you should learn two definitions of SI unit in today's class. One is for torque, what we saw, that is Newton meter. Dipole moment, what you saw, that is Coulomb meter. So keep both in mind. This is the direction of your torque. It is between P vector and E vector, and it has to be perpendicular to both P and E vector. T denotes the torque here. It will be into the plane in the sense it is a three-dimensional diagram. So you just keep in mind it is perpendicular to both P and E, and it will be into the plane containing P and E vector. Now we have three cases here. If this theta is the angle between dipole moment and electric field, if it is equal to 0. What is sine 0? Komala, what is sine 0? Mic is on. Lahari, sine 0. How much is sine 0? Anybody else knows the answer? Raise your hand. Sine 0.
0, ma'am.
Yes, Komala. How much is sine
0,
0?
ma'am.
Very good.
0.
So sine 0 is 0. 0 multiplied by anything, what will you get? Again, it has to become 0. So if theta is equal to 0 degrees, what will happen to this expression? Sine 0 will become 0. 0 multiplied by PE also will become 0. So your torque also should be equal to 0. So first case, if theta is 0 degree, then torque also equals 0 degrees. Second case, if theta is equal to 90 degrees. Dhanlakshmi, how much is sine 90? Aisha, sine 90?
1, ma'am.
Very good. Aisha has given us the right answer. Sine 90 is 1. Preeti, yes. If you write sine 90 is 1, PE into 1, what will be the answer? Preeti?
Ma'am, 1 second, ma'am.
Okay. Sine 90 is 1. That answer was given correctly. Now in this expression for torque, substitute value for theta is 1. What will be the answer for
Yes, ma'am.
T?
1 is 0.
No, sine theta is 1. 1 multiplied by PE, how much will you get?
1 multiplied by
PE. Sneha Purushothaman, very good. Today, first time she's raised her hand. What is the answer, ma? Anybody among the three? Sneha can unmute your phone. Unmute it. Torque will be equal to PE into 1. What will be the answer?
PE, ma'am.
Very good. PE is your answer. So torque equals P into E if theta is equal to 90 degrees. Usha, you have any doubts? Your hand is raised. You want to ask anything, Usha?
No, ma'am.
Okay, ma'am. So first case is if theta is equal to 0 degrees, then torque is equal to 0. That's the minimum value. Case 2, if theta is equal to 90 degrees, we know sine 90 is 1. 1 multiplied by PE will give you PE. That is, torque will have maximum value. 1 mark question, keep in mind, when torque has maximum value, you should write theta equals 90 degrees. When torque is 0, when theta is equal to 0 degrees. So these are the things you have to remember in case of your torque. Third case, if theta is equal to 180. You know, 180 degree is a angle in a straight line. So always sine 180 is also 0. So automatically 0 into PE will give you 0. So two conditions, if theta is 0 degrees or if theta is along a straight line. You can see the diagram here. P and E should have 180 degree if they are along a straight line. Then again, torque will be equal to 0. Only when they are perpendicular to each other, we will get the maximum value for your torque. So we will see how to derive this expression for torque acting on a dipole placed in uniform electric field. It can be a 3-mark question for you. So for diagram, you will draw two charges, plus minus Q here and plus Q on top. Label it as A and B. And you have to write the distance of separation as 2L. Bottom it is minus Q at A plus Q at the point P. Look at the direction of the force. One force should be in the outward direction. From A, it has to move this side towards the negative x-axis. Again, from B, it has to move towards the positive x-axis. The whole arrangement, you should put it in between parallel lines which are denoted by capital E. This is your diagram for torque. I will repeat it again. So what you're going to do here is, you will draw 2 points, one at A and the other one at B. So when you draw it at B, the point here will have force of plus Q. Line should be outward. Here you will write it as minus Q. Distance of separation should be equal to 2L. Then parallel lines which indicate the symbol E. We'll move on to our derivation now. Force acting on the positive charge F1 will be equal to capital E multiplied by Q. So this is F1 for us, that is acting on the positive charge. Positive charge means at the point B. Same thing but for the negative charge. Force acting on the negative charge F2 will be equal to E into Q. Same formula will apply for F1 and F2, but in opposite to the direction of the field. Only this point you should keep in mind. One is in the positive direction of your field, the other one is in your negative direction of the field. Value is the same. F1 equals E into Q. F2 also equals E into Q. Since left hand sides are equal, I can equate my right hand sides. F1 is equal to F2. I told you the definition for a couple. Two equal and unlike. Unlike means one should be positive, the other one has to be negative. So two equal and unlike parallel forces will constitute a couple. So what is a couple? Two equal and unlike parallel forces will constitute a couple. This will tend or this will make to rotate the dipole in the direction of the field. So when it is rotating, automatically what will we get? We will be getting a torque. So the moment of the couple or torque acting on the dipole will be given by the formula. See, this is a Greek symbol. We write it as tau, T-A-U. You'll put one horizontal line like an inverted C, it has to be written. So this is the symbol for torque and I denote the symbol by T-A-U called as tau. Formula for torque is force into perpendicular distance between the forces. What is the force we have got? It is E into Q. In your diagram, you see clearly perpendicular distances from B towards C. So you write it as BC. Same thing what we did in the previous thing. What is the perpendicular distance? Sine theta is opposite divided by hypotenuse. So if I want only the perpendicular distance, it will be sine theta multiplied by 2L. That's what is written here. 2L into sine theta. You can see the explanation given here. In the triangle A, B and N, sine theta is BC divided by AB. You can see your triangle here. It is A, B and C. Theta is here. So opposite side is BC, hypotenuse is AB. If you want BC, what you should do? Cross multiply these two. You will get AB into sine theta. AB is nothing but 2 into L into sine theta. That is what is substituted here. And dipole moment, we have the formula. By this time, we have repeated it so many times. Dipole moment P is equal to Q into 2L. So your torque will be E as it is. Instead of Q into 2L, write it as P multiplied by sine theta. So this is the derivation for your torque. You should do the diagram. First point will be force acting on positive charge. F1 is E into Q in the direction of the field. Direction is very important. It is along the direction of the field. Second point, force acting on the negative charge. F2 equals E into Q and that will be in the opposite direction of the field. Both are equal. F1 equals F2. Since these two equal and unlike parallel forces, unlike because opposite direction, they constitute a couple. This couple will have rotatory effect of the dipole, which causes the torque or moment of the couple. Formula for torque is force into perpendicular distance between the forces. So torque is equal to EQ into BC. BC is your perpendicular distance from diagram, that is equal to 2L into sine theta. If you write this, Q into 2L is nothing but P here. So torque is equal to E cross P sine theta. This is the formula for our torque. So having learned about what is an electric dipole, what is dipole moment, what is torque, and what is its expression, we learn one small statement. It is called as your Gauss law in electrostatics. So what is the statement of the law is? I want you to learn it up quick. The total electric flux through any closed surface will be equal to 1 divided by epsilon naught. We call this as epsilon naught times the total charge enclosed by the surface. So the total electric flux through any closed surface will be equal to 1 divided by epsilon naught times the total charge enclosed by the surface. Tomorrow's class, keeping this law in electrostatics, we are going to see two applications of the law. So we will be deriving two expressions. By that time, I want you to just learn up this definition for the statement. Electric flux is total lines which are there through any closed surface should be equal to 1 divided by epsilon naught times the total charge enclosed by the surface. Arshia, you want something?
Ma'am, I know this, ma'am. I have learned.
Okay, can you tell it?
Yes, ma'am.
Repeat the statement.
The total electric flux through any closed surface in free space is equal to 1 by epsilon naught times the charge enclosed by the surface.
Very good, Arshia. Very good. You learned it quick. Excellent. Superb. Nice. So I want all the others also to learn it up. The total electric flux to any closed surface will be equal to 1 divided by epsilon naught times the total charge enclosed by the surface. If anybody has learned it up, you can raise your hand and tell me the answer. Ashwini. Yes. Ashwini. Preeti S. Swati K. You can unmute your mic. Vishalakshi. Preeti
The
S.
total
Yes.
electric flux through any closed surface is equal to 1 by epsilon naught times the total charge enclosed by the surface.
Very good, Preeti. Very good. Swati will try.
Flux any closed surface is equal to 1 divided by epsilon naught times of total charge enclosed by the surface.
Very good, Swati. Rightly said. Very good. Sneha will try. Sneha Purushothaman.
Yes, ma'am. The total electric flux through any closed surface is equal to 1 by epsilon naught times the total charge enclosed by the surface.
Very good. Perfectly told. So the answer is exactly correct. That is how many others also have raised their hands. We will do one small derivation and I will ask this question again. So here we are going to see what is the work done on an electric dipole in uniform electric field. So when a dipole is placed in your uniform electric field, it experiences a torque. So whenever a dipole is placed in uniform electric field, it will experience a torque and it will tend to align. Align means it will arrange itself in such a way so to attain stable equilibrium. Now you imagine you are all sitting in a room. We come into the class and tell you, take your places and sit down. What will you do? You will try to move yourself and arrange yourselves and settle down so that you are comfortable in that place. Same thing happens here. If a dipole is placed in uniform electric field, it will have some force. So there will be a torque or that twist will happen and it will try to move itself and align in such a way to attain stable equilibrium. It should be comfortable. It should have that stable position. Till then, it will be keep on moving around. That is called as the rotatory effect or the torque. So what happens at that time when a dipole is placed in uniform field is it will experience a torque twist and it will keep on moving to align itself in such a way as to attain your stable equilibrium. Now when it is doing that, it has to have some work. When it is moving itself and trying to establish that stable equilibrium, it does some work. That work done is denoted by the symbol dW. Formula for dW will be T into d theta. T here represents your torque. So last derivation we saw T is equal to PE into sine theta. So I'm writing the same formula. For T, it is PE sine theta multiplied by d theta. We have to integrate this to find out the total work done. See, work done in for a single particle is dW. Total work done means we have to integrate it between theta 1 and theta 2. So when we integrate the same formula, PE sine theta d theta, your PE is a constant which will come outside. Integration of sine theta is cos theta. Since we have two limits here, theta 1 and theta 2, my formula will be cos of theta 1 minus of cos of theta 2. That is lower limit minus upper limit. I'm repeating this. Work done is integration theta 1 to theta 2, PE sine theta into d theta. P is a constant taken outside. Integration of sine theta into d theta is cos theta. Limits are here. So it will be cos theta 1 minus cos theta 2. So this is the formula for work done. If the potential energy is arbitrarily taken 0, that is when the dipole is at 90 degree, then potential energy in rotating the dipole, if you have to rotate the dipole and incline it at an angle theta, your formula will become potential energy is denoted by the symbol U. That will be equal to minus of PE into cos theta. So this is the formula when your dipole is acting at 90 degree. Potential energy can be taken 0 at any position of your dipole. So we can assume the position to be at 0 at any point. If it's just work done in terms of cos theta, this will be your formula at 90 degree. Formula for potential energy will be U is equal to minus PE cos theta. We have three conditions. If theta is 0, you know cos 0 is 1. So if theta is 0, your energy for potential energy will become minus PE. That is the stable equilibrium. In